All right, so what 21 is asking us to do is to find a unit vector. A unit vector has a length of 1. That is what the definition of a unit vector is. So a unit vector, think it fits on the unit circle. It has a length or a magnitude of 1. That's what it means for it to be a unit vector. So we want it to go in the same direction as A. So the way that I have kind of wrapped my brain around this is if I think of separately a random line segment, and I tell you that this is maybe 12 inches long, and I want to find a piece that's 1 inch long, what do we do to get there? How do I take a 12-inch segment and make a 1-inch segment? We would divide by 12. So we're dividing by the total length. So when we're looking at a vector and I want to get a unit vector, I'm going to take the length or magnitude and we're going to divide each piece by that magnitude to make it be down to 1. So we're going to start with finding the magnitude of A. So the magnitude of vector A remember our magnitude, that's the square root of the square of each value. So we'll take our -5 squared plus 3 squared. Gosh, my handwriting is trash today. There we go. So our magnitude of A is going to be the square root of 25 plus 9. So our magnitude is going to be the square root of 34. That's the magnitude of A. So to find a unit vector that goes in the same direction of A, what we're going to do is we are going to take and multiply our whole vector, the -5 comma 3. And just like we were thinking for that line segment, we would divide it into 12ths. I would divide this each term by the square root of 34. So it becomes a scalar multiplication if I write it as a fraction. But what I'm doing is I'm taking my -5 and dividing it by square root of 34. And I'm taking my 3 and dividing it by the square root of 34. And that gives me my unit vector. This is not pretty. That is the ugliest thing ever. So on this one, we can either switch it to decimals or you can rationalize it. Rationalizing these does not make them any better. It still looks awful. So I'm going to put these as decimals. So we're just going to take -5 and divide by the square root of 34. As a decimal, it gives us -0.86, rounding. And 3 divided by the square root of 34 gives us 0.51. And then if you went and found the magnitude of that, it would still have a magnitude of 1 because it is a unit vector. We took our total length, our total vector, and divided it into the magnitude. That's how we create a unit vector that goes in the same direction. Why we need a unit vector that goes in the same direction, I have no idea. But that's a thing that they want us to be able to do. It's not a thing we focused on, but I wanted to do that. So if it says to make a unit vector that goes in the same direction, you're going to find your magnitude and divide each of your terms by it, and then you can round it into a decimal place. Because you have to either rationalize it or make it a decimal. So it's a little weird, but questions on this one? It's not a difficult calculation, it's just weird. Okay. I think the only other one really in here that felt like we didn't hit anything super close to it was the tide problem. There we go. Because this was a story problem about a trig function. It's number 8. And so it's thinking about our trig function here and kind of thinking about it in a different way, but it's not things we haven't done. So we're going to think about a sine function. And we know that sine functions have a range from -1 to 1. Like, that is one of the things that defines them. If I think of sine function, it's this guy. Okay, I'll send it. That is the loudest set of headphones. Oh my gosh. And so what they're asking about for part A is how deep the water will be at high tide. So we're thinking about the kind of maximums here. So what is the maximum value on a sine function? 1. So this piece at maximum is going to be 1. So at high tide, where it's at its very highest here, the depth of the function, or the depth of the water in whatever port this is 2 plus 1/2 times 1. So how deep will the water be at high tide? 2 and 1/2. Yeah. 2.5 meters. Part B is almost the same. If we're looking at low tide, how low can the sine function go? What is its lowest? -1. So again, looking at my function, if my sine function goes to its absolute lowest, how deep will the water be at low tide? The depth is given by our equation. Same, just like part A. 2 plus 1/2, and then the lowest my sine function can go is -1. So what is the absolute lowest that the water is going to be at this pier? 1.5 meters. So C is kind of a weird one to wrap our brain around again. Middle tide occurs when the water is exactly halfway between. So what is the value of sine at mid-tide? If high tide is when sine is 1, and low tide is when sine is -1, what's the middle? 0. So this is looking at when sine is 0. But we're not asked for the depth this time. We're asked at what time. So I want to know when this piece of my equation equals 0. That's the piece that's changing. So I want to know, when does 1/2 sine of pi over 6 t equals 0? That's what we're trying to solve here. I'm going to zoom it in so we can actually see stuff here. So what could we do to solve this? What's going to be our first step? How could I get t by itself here? What do I need to get rid of first? The 1/2. We're going to get rid of that by multiplying each side by 2. So we're going to have the sine of pi over 6 t. 0 times 2 is still 0. So I'm going to do this as kind of like a u substitution because we don't like dealing with those kind of gross things in there. So I want to know, when does sine of u equal 0? Doing it as a u substitution. What would our u be? When does sine equal 0? Say it again. At 0, 2 pi, and there's one more in between them. At pi as well. So it happens every pi. So this is back to thinking when we were solving for all possible values. So 0 plus pi n. Because it happens at 0, it happens at pi, it happens at 2 pi, it happens at 3 pi, it happens at 4 pi, it happens at 5 pi, it happens at 6 pi, and so on. But again, we didn't want to know when u equals 0. We want to know when pi over 6t equals 0 plus pi n. Oh, sorry. My computer gets grumpy if I try and check my emails while I'm doing stuff. So again, I'm trying to get t by itself here. What can we do? Yeah, multiply by that reciprocal times 6 over pi. If you want to do it in 2 steps, you absolutely can. Times 6 over pi times 6 over pi. So these guys all cancel out, and we're just left with t. 0 plus, my pi's cancel out, and my screen just froze. Love that. I think Annotate has also, my software has also decided that it's ready for summer. No, the whiteboard is indeed available. Oh my gosh. Quit telling me you're connected because you're not. Close. Gotta get grumpy. There we go. Finally got it to realize it's not connected. Come on. Oh my gosh. There it goes. Huzzah, we're back. All right. So in here, we're simplifying this. Our t equals 0 plus 6n, because my pi's canceled out. So what this means is that this tide cycle repeats every 6n. It'll be at mid-tide. So if my first mid-tide is at 10 a.m., what is my next one? What is 6 after 10? So 10 a.m. is our first mid-tide. 4 p.m. And 6 more hours later, 10 p.m. So we were looking for that mid. When? This means we're solving for t. So this next one is very similar, and I'm going to leave D for you to do. What time does it reach high tide? We're not looking for 0. We're going to be looking for when our sine function equals 1. Yeah. So that's what we're looking for here. It's still looking at our sine function. It's still solving for all values. It's just looking at it kind of weird. It feels weird. Because we did not do a ton of story problems with these. Because honestly, the story problems for these are super gross. Are there any other problems that you guys have come across in this that you would like to work through and you're not sure what or why something was done? Not just what the answer is, but why. That's what we're looking for mostly here.
Can you go back real quick?
Yep. Sorry, it was just my screen freaked out. And I can zoom it in just a smidge just so that everything's a slightly better size. There we go. And all of this is up on the answer key that is up on the Canvas page. Okay. So Monday we can do a similar kind of vibe where if you guys want to work through some together, we can, or if you want to work on your own, totally fine. You at this point in time, you guys know how to study and what's best for your brain. So I'm going to let you go with that. If you got questions, I am happy to go through stuff with you. If you would prefer to work by yourself, totally fine. If you want to work with a friend, I don't really care. Rock on, do your thing, ask questions. Answer key is posted. I am happy to help. All that jazz.